Hello everyone. Last week we talked about shear moment diagram. We saw 2 examples, and in this week we will continue on the same topic, but like a more complex example. And there's a new support that I would like to talk about it. That is the fixed support. So before talking about the fixed support, let's solve another example. Let's make some refreshment to your mind. نفسي مرة تيجي على الموعد. تعرف المرة الجاية أنت 3 تيجي على الموعد. قسما بآيات الله ما بتروح. ضل فيها ضل فيها طبعا. في الجمعة واللي بعدها.
إن شاء الله خير.
إن شاء الله. على البهدلة طبعا بقلاقي يعني. تفضل. ابعد عنها والله. اقعد. Okay, as I said before, in the last week we talked about the shear moment diagrams, and we will continue on the same topic as this week. So let's start with an example to refresh your minds. So let's imagine that we have a beam. And the load type in this beam is no, not good. And we have a load on the speed like this. And the load type, or the load magnitude is, let's say 15 kN per meter. And the length of this beam is 3 meters. This point is a point A, and this point is a point B. Okay? So let's solve this example. I'm still recording, right?
Yes.
There's a tag. Perfect, okay. So, if you had like this question in the exam, the question will be draw the shear and moment diagram for this beam. Okay? So the question is draw shear and the moment diagram for this beam. So the first step is, what's the first step to draw the shear and moment diagram? Reaction. Yes, the first step always is to find the reaction. So the first step always is find the reaction. And please, in the final exam, do it well. This step is the most important step. Do it well, because if you find the reaction wrong, all the question will be wrong. Okay? All the question will be wrong. Yes, if you find the reaction with the wrong numbers, all the question will be wrong. I will not have a look on the, let's say, the remainder of the question. Okay? Because it's all of this attend to this one. Okay? So let's find the reaction. Here we have a hinge support. So it's AY and AX, right? And here it's a roller support, so we got BY. Okay, let's find the reactions. The first equation is the summation of the forces in the X direction should be equal to 0, right? So what the forces on the X that we got? AX. Just AX, right? Just AX. So AX will be equal to 0. This is the first equation. Or the first equation. Okay, the second equation is the summation of the forces on the Y is equal to 0, and it's okay. What the forces on the Y that we got? AY. Okay.
This 15.
Plus BY. Okay. And now we have triangular load, right? And I explained how you can deal with it in the last lecture. So what we should do with it?
1 by 2 multiplied by
1 by 2 multiplied by 15, the magnitude of the load, multiplied by the distance, 3, yes. And this is equal to, it's a 45 divided by 2, 27.5, right? 27.5 kilo in Newton. Okay. We find the magnitude of it. Now, we turn this distributed load into the point load. Let's say now we have a P.
22.5.
What?
22.5.
Yes, 22.5. Sorry, 22. It's a 45. 22.5. Okay, so this distributed load gonna be turned to point load. It's 22.5, right? So after we find the magnitude of this load, we should find the location for this load. So where's the location?
From this side, 12 by 3.
Okay, from this point, how much should I go? 1 meter, right? It's a 3 over 3 and it's a 1 meter. So all of this will be replaced by a point load which is equal to 22.5 kilonewton, and this distance from here to this load is 1 meter, and the remaining distance from here to the point B, it's a 2 meter. Is that correct? Okay, up to this point, any question?
No question.
Okay, perfect. So AY plus BY will equal minus 22.5, and all of this equation should be equal to 0. Finally, the third equation to find the reaction is the summation of the moment, let's say about 0.0, and should be equal to 0. And I will consider that the clockwise direction is the positive one. So, what we have?
Plus.
All of us agrees that AY and AX does not make any moment at the point A, right? Okay. Now, we have a 22.5. Is it make a clockwise positive moment or a counterclockwise moment? Clockwise positive moment. So it's going to be 22.5 and it's positive multiplied by 1. Perfect. Multiplied by 1. The distance is 1. Okay, and we have also BY. BY make a moment at the point B, and it's a counterclockwise, so it's a negative sign. So minus BY multiplied by 3. Perfect. And it's equal to 0. Thus indicate that BY is equal to 22.5 divided by 3, right? 22.5 divided by 3, it's 7.5. Okay, so BY is equal to 7.5 kilonewton. Perfect. So we find now BY, right? According to that, if I take BY and apply it into this equation, I can get AY. So AY should be equal to 15, right? 50. Okay, this is the first step. We find all the reactions, AX, AY, and BY. And come in. No way. Okay, let's continue. And let's have a note of this one, because BY is positive and AY is positive too. That means the assumed direction for AY and BY was correct. Both of them are upward forces. Okay? So I think up to this point, all of you can find the reactions. Right? It's an easy process, not a complex thing. Okay? Let's now go forward to the second step. Let's go now forward to the second step. Okay. Now, after we find the reaction, we should start drawing the diagrams, right? Okay. We have, this is the support that we was got, like this. And there is a load. The load was like this. The value of this load was 15. And the length of the beam was 3 meters. This was the point A. This was point B. We agreed that AY is equal to 50 and the BY is equal to 7.5 kilonewton for both of them. Okay? Kilonewton for both of them. By the way, does anyone watch the last lecture on YouTube?
Yes.
Is it good? Like the voice and the quality or something like that? Is it good? Yeah. Because I can improve the quality if you want. If you want, I can improve the quality. Okay? So if you have any notes on the quality, just tell me. Okay. Now let's start drawing. Okay? This is the beam that we got. We find the reaction. We should start drawing. Okay? Now This is the shear force diagram again, SFD, shear force diagram, and up here is the positive, down here is the negative. After that, we should draw M, B, D, which is moment bending diagram. Again, moment bending diagram. Up here is a positive, down here is a negative. Okay? Let's start over. So, starting from point A, and please all of you just have a lot. Focus with me, I will give you time to write, because this is one of the most important exams. Okay? So now, at the point A, we have reaction is equal to 15 kilonewton, right? And it's upward. That's mean, on the shear diagram, I should go upward like 15 points, right? So I will go upward here, 15 points, like this. It's a 15. Am I right? Good. After that, when I want to, like, let's say, walk after point A, there is a load, a distributed load. It's a 15 kilonewton per meter, and it has a triangle shape. Okay, that means, if you remember the last lecture, that means the triangle shape is from, it's a load from first degree, right? The degree for this load is the first degree because it's a line, right? And all of us indicates that the shear force diagram is the integral of the load, right? So if I'm here at the first degree, at the shear diagram, I should be at the second degree, right? I should be at the second degree. And the first degree is a line. So here, the second degree should be a curve. Should be a curve, okay? Up to this point, all of you can understand this, right? Okay, perfect. This load tell me that the direction of this load is downward, right? So I have a positive 15. I have a positive 15. I'm now here. And the effect of this load, we find the effect of this load. The effect was approximately here. It was 22, perfect, 22.5, and it was downward, right? Downward means a negative sign. So that means you have also minus 22.5, right? The result is
7.5.
perfect, minus 7.5. Okay, so I'm here now. I should finish at here, which is mean minus 7.5. I should finish here, right? Okay. Now the question is, how the curve should be look like? Wait a second, I will tell you. Okay, or tell me how the curve should be look like.
Because we should start with a number, so it will be like this.
Yes. So like this or like this?
No,
The second.
Yes.
The second. Okay. So here, as our friend says, that we have the two options. Okay, we got the two options on the shear diagram. Because I need a curve, right? I need a curve because I'm in the second degree. But when you think at this shear diagram, you will think with the two options. Maybe the curve will be like this, downward, or maybe the curve will be like this. Am I right? So, how can I choose this one or this one? As our friend say, Abdel Hadi, that we should choose this one. Why? Because here in the shear diagram, we start with a value. And here we start with a value, right? So this triangle here is starting with a value, and at the end should be equal to 0. How we can discover that here? By the slope definition, right? So the slope here for this curve is horizontal, right? What the meaning of the horizontal slope? 0. I told you that before. The meaning of the horizontal slope is 0. So it's not the same here because it's starting with a value, not with a 0. But here, the slope here is not horizontal, right? That means it have a value. So I should choose this one. So I will move like this. I will move like this. Is that clear? Any questions so far? Perfect. So, like this one, now I'm at minus 7.5. At the point B, Vy is equal to 7.5 upward, right? So, if I go up, I will end with 0. That means my solution is correct. If you end with a 0, that means your solution is correct. Because as I said before, always on the shear moment diagram and the moment diagram, you should always end with a 0. Okay? If you end with another value else, that means your solution is incorrect. Okay. Again, I will ask you, up to this point, anyone have any questions? Yeah, please.
Sorry, I was first class. I don't understand the first degree and the second degree curve. I don't. How do you come about it?
You didn't understand the concept of this one?
Yeah, the first degree and the second degree.
Okay, okay. I will explain to you. So, here, this load, okay? It's triangular load, right? So, this is the load. And this is, you see the line here, right? So this line is, let's say, a straight line, right? And when you have a straight line, this means that you get a function from first degree, right? Like, let's imagine that you got fx is equal to x. Okay? X is a function from the first degree. And the diagram for x is like this, right? Okay. Now, when you move to the shear diagram, that's mean when you are here and you are moving here, you should make an integration process. Okay? When you make an integration process, always the power or the degree will increase by 1. So you are in the first degree. When you are doing the integration, you will move to the second degree. Okay? If you imagine this on the x, the integration of the x will equal to x squared over 2. That means the power here for the x was a 1, and now it's turned to 2. That means you got a curve, because any second degree function come in, any second degree function is a curve. Okay? You got it now? Perfect. Any other question? Okay, let's continue. Now, after we calculated the shear moment diagram, we should focus on something important. That all of us agree this is a positive area, right? Yes. Because it's in the positive region. And this is a negative area because it's on a negative region, right? And all of us agree that, this one, at the moment bending diagram here, all of us agree that the moment is the area under the curve, right? You remember this one. What the meaning of the moment here? The moment is the area under the curve. Under the curve. It's the area under the curve. Okay. Now, if I want to calculate this area, can anyone tell me what is the area for this one?
Yes. This distance is 3 meters.
This distance is?
This is 1.5 meters.
This is 1.5.
Yes.
No.
1. Similarity triangle.
We should use.
Perfect. Yes.
Yeah.
We should use the similarity of triangles.
Yes.
The concept of similarity of triangle. Because we don't know here how much this distance, right?
Mm-hmm.
We don't know how much this distance. So, this distance here is x, right? And here, it should be 3 minus x. So, tell me, both of you, Shaheen and Kusha, you say we should use that similarity of triangles, right? How can I use it? Because here it's not a triangle, by the way. This is a curve function. It's not a triangle, it's a curve. So tell me what I can do.
X over 3 minus x equal to 22.5 over 7.5.
This over this equal to what?
22.5.
22.5.
And
No. It's any other options?
So if you have to straight
Just raise your voice, please, okay?
if you draw a straight line like the sum of the area.
No.
Over the.
If you mean like this, a straight line?
Over some of the area will be like those area which is not in part of the triangle, that will be subtracted.
No. Because if you wait a second, if you draw a straight line, you will cut this diagram on another point. We need this point. If you have suggestions, say.
X over 3 minus X equal to 15 over 7.5.
15 over 7.5. Okay, let me, you have a suggestion?
Suggestion, but it's not about X, we can find it, we can use integration.
You can use integration. You can use integration. If you can,
We
use
don't
it.
have to use the X, we have to find the function.
Okay, that's what I'm saying. Can you find the function? Okay, so
I don't know how to find
let me show you what you should in this case. Okay, in this case, at this point, tell me, all of you please tell me, how much is the shear on this point?
0.
0. All of us know that, right? Because here the value is 0, right? So all of us knows that the shear here is 0. Okay. From this point, go back to the diagram. Okay? And make a cut. Make a cut. Okay? Let's make this cut. Let's make this cut. Okay. So. Okay. Focus on me, please, for that. We make this cut, right? That means that this beam is cutting into two parts, right? The right side part, this part, and the left side part, okay? And always you should take a part which contain the triangle, okay? So, this part here, this one, is a triangle, right? So you should take it. But this part here, on the left side, if you take this, it's not a triangle. You don't take it, okay? So let's take this part, just this part. And to take it, I will just draw with the part that I will take it, okay? It's like this. And this distance is equal to
3 minus
3 minus 6, right? Here, because I made the cut here. On the right side, it's 3 minus 6. On the left side, it's a x. Okay? Wait a second. It's 3 minus 6. Yes.
Can I say how you do it?
Okay, how you can do it?
It's 3 minus x times half, which is equal to 22.5. Then you can find x.
No. How much the load is here?
We can't find it, but we can find
Now, I have another, this is a triangle, right? When I cut it, I take the right side. So I get this new triangle, okay? So my question is simple. How much the value here?
3 plus X.
The value here is unknown, it's a y. We cannot know, okay? So you don't know, understand? Because this total triangle, the value for it was 50, okay? Now I made a cut. And I don't know how much is distance.
You take
So obviously, the value here is not known. It's a y. I don't know this one, okay? So, please focus with me now, all of you. Let's find first of all y, okay? From the similarity of triangle, we can say that this triangle, the value for it was 15, right? And this distance, the whole distance for this triangle was 3 meters. Perfect. Okay. This one is equal to y divided by
3 minus x.
3 minus 6. Right? So y is, and this one give us a 5, 15 over 3. So y is
15 minus 6.
15 minus 5x. This is the value for y. Right? And as I told you, this is the most important example because it's gonna be in the exam. Like this beam and this one will be a part of it. Okay?
Now you take the area of the triangle to find x.
No. There's no area, man. Wait a second. Okay, if I take the area, what should I do after that?
You find x.
How can I find it? Okay, I find the area. The area should be equal to what? Tell me.
22.5.
22.5. Please, wait a second. Please, all of you. Wait, I will give you time to write, I will give you time to ask. I will not go out until you understand everything. Okay? Wait a second. So we find the value of y. Up to this point. Any questions? You have a question? Yeah? Okay, it's perfect. So all of us agree on the value of it, right? In the first lecture, in the last week, I said this sentence that if you have a beam and you make any cut through this beam, okay? You made any cut through this beam. When you make this cut, there's three reactions will appear, right? Which is normal force, perfect, shear force,
Moment.
and the moment force. Am I right? Okay. On this part, on this cutting part, we will get perfect. We will get normal force, moment diagram, or let's say a moment value, right? And zero shear force, as he said, because there is no shear here, right? At this point where I made the cut here, at this point where I made the cut here, there is no shear force, right? It's a G. Let's like put in here for this one. It's a zero shear point. It's a zero shear point. Okay? It's a zero shear point. That means there is no shear here. At this point here, there is no value for the shear. So I will not draw the shear reaction here. Okay? You cannot draw the shear reaction at this point because it's a zero. Okay? And there's no meaning for the zero if you draw it. Okay? Now, after that, we know here we have a ruler support, right? And we find the reaction for this ruler. How was the reaction for this one?
7.5.
7.5. Perfect. According to this one, I can now apply this simple equation. The summation of the Fy is equal to 0. So what the forces that we get to the y? We have 7.5 upward, right? 7.5 upward, and we have this triangle. And this triangle, I should turn it into point load as symbol. So it's a minus because it's a downward, half multiplied with y. How much y is? 15 minus 5x multiplied with the distance, which is 3 minus 6. And all of this is equal to 0. Now you got an equation, right? This equation is with one unknown only, which is x. You can find now x, right? So let's find it together. You can use the calculator directly.
Yeah.
You know that. In the exam, you can put this equation in the calculator and it will give you the value of x. Write on YouTube how to use the calculator to solve equations. You will find the videos and just follow steps. Tell me. Or give me the calculator, please. Thanks. Still recording, right? Perfect. So it's a 7.5 minus half minus 5x. What is voice?
Slow.
Is equal to 0. Shift. So, okay. So x is equal to 1.267 meters. So this is the value of x. Okay? This is the value of x. Up to this point, any question? Is it to understand? Do you understand how we can find x value? Let's like make a revision for the steps quickly. Let's give a sample. Okay. So the first step was to find the reactions, and it's an easy step for all of you. Should be like that. After we find the reactions, we draw the shear moment diagram. Okay? Now, to draw the moment bending diagram, all of us should remember this concept that the moment bending diagram is the area under the curve. Okay? And let's be more specific, more accurate. It's the area under the shear curve. Okay? This is the curve that we get. The problem is that we don't know how much resistance, X. Okay? But we know something very important, that at this point, the shear value is equal to 0. So, from this point, if we go back to the diagram, if we go back to this beam, and make a cut, okay? And as I said before, always take the side that contain the triangle shear, okay? Which is here, in this case, the right side, okay? I made this cut. This distance was 3 minus x. But the value for this triangle is at null. So I call it y, okay? Now, let's find y in terms of x. Because I don't want to have two unknowns, y and x. I just want one unknown, which is x. So here, this step, we can call this step finding y in terms of x. So we find y in the term of x, and we find it that it's a 15 minus 5x, okay? And all of us agree again that in this point here, it's a shear, zero shear force, right? So if I apply this equation, which is the summation of the forces at the y is equal to 0, I will have this equation, okay? If I solve it, I can find x, okay? So before finding the moment, please write your notes to continue. If you need a time to write, because I need to get it.
Second.
You need the second one? Okay, but does anyone need this diagram to write? Or all of you on the second part?
No,
All of you on the second part? Okay, please. When you finish to me. You are on the first part?
Yes.
Okay, wait. Please. Finish this part and then move to the... Yeah.
How you write this one?
It's the value of this diagram is that.
And the distance force, how the force is.
Okay, what the force is the one that you have 7.5.
Yeah, that's different.
Okay.
But that's an area of the triangle.
Yeah, okay. It's a half.
Okay.
Multiplied by
You
the
make
value.
it, you make it a point.
Yes, I make it to the point. Yes. Yeah.
Definition of Fy. So we take
Please, I was not focused with you. Can you repeat?
in the next that word we took the definition of Fy. Why we took the area? Like why we don't really take y? Like 7.5 minus y.
Why we take the area?
Yeah.
Because it's a distributed load.
Okay.
Okay, you should always turn to a point load to apply it here. You cannot apply it as just a distributed load. Okay? You got that? As same as here. You cannot deal with a 15 kilonewton per meter unless you turn it into point load. And you cannot deal with this one unless turn it into point load, which I make it here. Okay? So this one here, this part, is the area of the triangle.
So if we take the distributed load, so in that case why we don't take the distributed load?
In this case,
No, yeah, okay, that where we find y, yeah.
okay.
Why we took the distributed load is point x, right?
Why we didn't take the distributed load?
No, 15 divided by 3.
Okay.
And we take here the...
Okay, because now I want to find the distributed value, not the equivalent value. Here you got this load, okay? This load totally is 15 kilonewton per meter. I have a similar one, okay? If you make it a point load, there is no meaning for the similarity of triangles. Now, this is the triangle. How much the value for this triangle? It's a 15. How much the distance for this value? It's a 3. For this one, how much the value for it? It's a y, I don't know it. The distance is 3 minus 6. So here, you you should apply the distributed value. But when you apply it here, it should turn to point value. Okay? Easy or not? Not? You have a question. Okay. Ask us.
Is there any possibility where the curve will start at 15 and end at 0? Like we
Is
went
there
to-
what?
Like any possibility
For-
for the curve will start at 15 and ends at the point 0, like the other side?
Start here and end here directly?
Yeah.
Yeah, there's a possibility. It depends on the question that you got.
So how can we take the...
In this case, there is no need for the cut because there is no zero force. I understand the question. I will not write it. Please focus. You mean, like if I have a sheet diagram like this, and I'm starting with a 15, is there any possibility to end like this?
Yeah.
Okay. Yes, for sure there is another possibility, and there is a possibility for this. It depends on the question. Let's imagine that the question is end like this. In this case, there is no need to make the cut because there is no force. This distance we know it already. It's a 3. But here in this case, why I made the cut? Because this distance is unknown. Okay? Good question. May I?
Yeah.
Continue? All of you finished?
No.
Okay. 2 more minutes.
When will the exam?
When will be the exam? I don't know.
No, I mean which week?
Which week? Maybe 14, maybe 15. I don't know. One of them. Okay. This week is the 12th week, right? It's week number 12, right?
This week we have 2 classes.
Yeah, you have a class on Friday this week.
Friday morning or
Friday, I don't know. I think at 1 p.m.
this one day?
Yeah.
Because
It's a Black Friday. Yes, it's a Black Hill. It's a Black Friday.
it's Golden Friday.
What?
It will be gold.
So teacher, the time.
Is it good?
Teacher,
It's a Golden Friday.
It will be gold.
teacher,
Okay.
teacher, the time should be 50%.
50%.
Yeah.
Sales on the lecture. Okay. You will get the sale. Wait, please. Shh. We are now on the 12th week. Okay, 13, 14. I think, please. I think again the exam will be at 11th of December. Is that okay for you? 11th of December.
It's 14th week. It's 14th week.
It's 15. 15. Because I have an extra topic for this.
Okay.
There is too much things that you should learn. Because the next semester I will not be here, so you will be on the mercy of Mr. Tamish. Okay? So you should learn everything with me. After that, go to Mr. Tamish. Yeah, what is your question?
اتوقع اكس صار
اتوقع اكس خطا عندي.
بس انا حليتها هيك بيطلع عندك 2.5 اكس سكوير ماينس 15 اوكي بتحطها على الكالكوليتر
ماذا مستحيل. Wait a second.
I have the last of the days too.
15 minus 5x multiplied by 3 minus x. مستحيل طبعا يعني. ضربته طلعت اقتران تربيع ضربته النص.
5 اكس سكوير ضربت النص تشيل
وهي تعرف إذا حسبتك صح بس أنا متأكد أنا متأكد لأن 7 ونص ناقص نص موجود عندك 15 ماينس 5 ضرب X. What? And all of this goes on equal to 0.
What's the
Wait
problem?
a minute. I will check that. That's separate. I will check.
Yes.
Serious. I will check it after finishing. Okay?
هسه تبين
Winnie?
هسه
May
تبين
I have your attention?
مش المفروض يبين بالمومنت بايندينج ده هنا.
We have 2 extra lectures, okay? So let's finish like friends with each other, okay? Yeah, I hope so. Okay. Moment training day. And let's stay friends because I'm teaching master's degree students and all of them are, let's say, older than me. I cannot say anything with them, but you are, let's say, so I can like say, put the blame on you, not on me. But in the master's degree students, there's like 3 or 4 students who get married and have children, and I'm just 24 years old, so let's stay friends, please. Okay? What?
This is all time to read.
Okay. So now, please. After we find the distance x and we find it, now we should find the moment. Now after we know this x, okay, we find x, and the moment concept is it's the area under the shear curve, right? Can anyone tell me what is the area for this shape?
Yes.
Yes, tell me what is the area for this shape?
It's 1.267 times 15 times half.
This shape, it's like this, okay?
Oh,
It's not a triangle.
it's not fine.
It's a curve. Do you know what the name of this shape? What the name of this shape? This one. No, it's not a parabola.
Half of it.
It's x parabola.
Yeah, that's what I mean.
This one, it's a x parabola. It's a x parabola. Okay. How much the area for the x parabola? Since you know
We can calculate it.
yeah, I know we can. How much is it?
How much after calculation we can get?
Okay. So in this example, okay, here, it's not necessary to know the area for the x parabola. And I will not ask you in this course what the area of the x parabola, okay? There's another way to calculate the moment. What is this?
Can I get the graph?
What?
Can I get the graph? Like, it should be like this.
You will guess the graph. Now you will see it. Wait a second, okay? Again, as I said, it's not necessary to find the area for the x parabola, okay? So in this course, I will not ask you about how much the area of the x parabola, because there is another way to find the moment here. What is it? Is to use this diagram again, right? How can I find the moment? Okay. By the way, if this, let's see, remember that x was 1.267, right? Okay. Now, how can I find the moment? There's a moment reaction here, right? So, let's apply the summation of the moment at point. Let's say this point, point B, okay, should equal to 0. Clockwise is opposite. Okay? So, what are the forces that make a moment here at the point B? 7.5 does not make any moment, right? Because it's on the point B. All of us agree on that. Okay. Now, the normal force and that we got here, if you extend it, it will cut the point B. There is no moment for the normal force. And always, by the way, there is no moment for the normal force. Always. Now, we got here a moment. It's like a concentrated moment, okay? So it's m. This m, it's a clockwise, right? Or a counterclockwise? Counterclockwise. So I will put it here, minus m. I don't know how the value for it. Just a minus m. Okay? Finally, we have a p, right? The value for p is this point load. P, it's right here, is equal to half multiplied by the distance, which is 3 minus x. Now I can have this distance. It's a 3 minus 1.67. 1.743. Right? Okay. Multiplied by y. Y was 15 minus 5x. Can you find the value for the y? It's a 15 minus 5x. Multiply 5 with the x, then abstract
It's 1.733.
1.7.
No, the for P. There.
Okay, it's 1.733.
733. No, instead of the 1.743, it's 1733.
Oh, come on, man. Come on, man. It's just a one single digit. Okay? One single digit. And it's here. It's not effective. 3343. Write it in the exam until here, and I will consider it as correct. Just write in the exam 1.7. 433, 333. It's a fucking issue, man. Okay, now the value for y is
8.665.
8.665.
Yes.
Okay, so multiplied with 8.665. This is equal to B.
7.51.
7.51. All of you agree on this value?
Yes.
Yes. Should be like this because it's approximately on the half. And it was like 15, so it's correct. But please calculate it again. Just let me check. It's 8.665 multiplied by 1.743 multiplied by the half. Yes, perfect. It's a 7.5551 by the way. That's it. Okay. So we find P. Now, please, all of you. So P is 7.51. Okay? P is 7.51. And P is making a moment here at M. The moment here at a B, sorry. It's a counterclockwise, right? So it's a minus. And the value for B, again, it's a 7.1 multiplied with the distance. How much is the distance here? How much is the distance? 1.743 multiplied by 230, right? Because this distance here, this one, we find it's a 3 minus 6, right? And it's equal to 1.743. And the distance here is 2/3 of L, right? It's a 2/3 of L. So this one multiplied by 2/3 of L, and it will be equal to 0. Now I can find the moment, right? Now I can find the moment. So the moment is 7.51 multiplied by 1.743 multiplied by 2 divided by 3. So the moment is M is equal to
8.715.
8.7.
15.
It's like 0.72. Okay? It's with a negative sign. Okay? Yes, it should be clockwise. That's here. It's negative with a negative sign. That means, please, all of you focus. We find M here. Okay? We find M here. It's the unit for it is a kilonewton. We find M here. And the M was a negative sign. Okay? That means that the direction that I assume M here is wrong. I was assumed M as a what? Counterclockwise. It should be clockwise. So it's equal to 8.72 clockwise. Okay? So please, all of you, just have a look here. Please have a look. So we find the moment here. The moment at this point also, we find it, right? The moment at this point was It's a 8.72, right? And it was a clockwise moment. That means it's a positive moment. According to the table on the past lecture, it was a positive moment, right? So now I'm here at 0, okay? And the moment here is a 8.7, okay? And this is a positive area, so I should move from here to this point, right? But this here is a second degree curve, right? On the moment it should be third degree curve, okay? And I give you a simple rule. I give you a simple rule in the case of the moment. Just imagine that there is a line between these 2 points, okay? And make a curve above it. Okay? Now, can anyone tell me directly, please, focus, how much the area for this diagram?
It should be the same, but negative.
Perfect. The area for this one should be the same of this one, but negative. Because always I should end with a 0. So there's no need to calculate this area. It's always like this. Okay? And this is the moment diagram. We finished the exam. Fine. Have a time. If anyone have a question, please ask it. Do you need the second part? Or the second one?
Can you explain the moment we find again?
How what?
The moment we find.
The moment.
Yeah, can you explain it?
Okay. Again, at this point, here, I should find the moment.
Yeah.
The moment here is equal this area.
Yeah.
Okay? But again, I will not ask you about the area of this one. It's not in this course. I will go back to the cutting diagram, the cutting figure, this one. The cutting figure contains moment, reaction, and the normal. The moment reaction is the same value here. Okay? So my job now is to find the moment reaction here. How you can find it? By using equilibrium equation, which is the summation of the moment at a point B should be equal 0. Okay? 7.5 does not make any moment here. The normal force does not make any moment here. Wait a second. Now, what's the moment that we get? We have M, and M it's a counterclockwise, so I put it a minus. And we have the triangle moment. So I find P and multiply to the distance, and finally I have M with a negative sign. So it's that negative sign mean here that the assumed direction for the reaction was wrong, right? So the correct direction, because I was assuming like a counterclockwise, so the correct one is a clockwise. According to the last lecture, I give you a table to help you how you can draw, right? And if you have a clockwise moment, it's in the positive region, right? So here, the moment should be 8.72 at the positive region. Okay. Now I'm at the 0 point, okay? I should move from here to here as a curve for sure, because you are in the second degree, you will move to the third degree. So I give you a simple rule. Just imagine that there's a line and draw a curve above it. And there's no need to calculate this area, because obviously the area here should be a negative of this value, because I should end always with a 0. So just go to the 0.
Can you open the other one?
Yes, for sure.
We find the y again 7.5. We multiply 7.5 to
Wait a
the
second.
distance.
Here?
Yeah.
Oh.
7.5 multiplied by the distance, that is 1.740. Why 2.2 divided by 3, like 2?
Why 2 by 3?
Yeah.
You shouldn't ask like this question.
No, I know what from, like, we have to multiply both distances.
No, not both distances. Wait a second. This is the distance. Okay. The distance here is 1.743. It's a 1.73. Okay? There's a student who asked. All of you should shut up your mouth. Okay? So it's a 1.73. And this value here, it's a 1. We find it, right? We find it. Okay? So the load here is P. I want to find the point here at this point. At the point, right? So the location for this distance, how much is this distance? It's, as I said in the last lecture, from this distance it will be 1/3 multiplied by L. From this distance should be 2 by L, 2 by 3 multiplied by L. and this is it. You got your answer?
Yeah.
Okay, so now when you find the moment, 7.51, okay, this one is the value of p. Multiply by this distance, which is 2 by 3, multiply by this one. Good. Take a time to write all the report. Okay? Is that clear to this point? Do you have any question? Shahid, I think that you are missing something,
I
right?
have a question, but not from this question. I solved one yesterday.
Okay.
I think
You solved one yesterday. What was the shape for it? Can you draw it here?
Yes.
Come. And please, if anyone have any question, don't hesitate to ask. Okay? Because this is the most important material in this course. Come.
It's about the moment.
Okay. Okay. Show me the question. What was the question? Do you remember?
Yes. I think we solved here.
I think, can you draw the mean? What was the mean? And the load for it? It's for my examples or an extra example?
We solved here, I think, but
It does not end with a 0?
this end, the shear is end, but the moment it was complicated. The graph and it didn't like
عندك المثال الكتاب اللي دفترك؟
بس انا متذكر كيف كان
طيب اسمع بعثني اليوم على الفيسبوك. اوكي. And by the way, as I said before, the shear diagram, okay, should end with a 0, right? And the moment diagram should end also with a 0, right? But if the shear diagram ends with a 0, that's not necessary to mean that your solution is correct, okay? Not necessary. If you want to have say 100% that your solution is correct, both of them should end with a 0. Because sometimes your solution will be incorrect, okay? But the shear ends with a 0, but the moment will not end with a 0, okay? So, to have a sign, let's say, okay? To have a sign that your answer is a 100% correct, both of them should end with a 0. So the rule says that if the shear ends with a 0, that's not mean that your solution is correct. Okay? You got that? Now, let's solve another example. Okay, before solving another example, any question? Okay. So, let's move to another. Okay, now in this example, okay, we will deal with a new support, which is the fixed support, okay? And you should learn how to deal with the fixed support. So, this is the fixed support. Okay, this is the beam that we got. Let's imagine that we have a load here. It's a distributed load. It's equal to 20, for example, 20 kilonewton per meter. The distance here is a 4 meter. This is a point A. This is point B. Okay. Now, before starting this example, the fixed support, I think I say a few words about it, right? The fixed support have how many reactions that? 3 reactions. Perfect. We have, if this is point A, we have AY, we have AX, and we have moment A. Okay? So the fixed support have 3 reactions. X, Y, and the moment. Okay? Now we will solve this example, sorry, and learn how we can deal with it. Okay? Learn how we can deal with it. But before that, does anyone know? Oh, sorry, you need this one? Does anyone know in the reality, in the real life, okay, what is the difference between the fixed and the pin support or the hinge? What is the difference between this one and this one in the real structures?
Probably not.
The hinge should be like foundation. It's foundation and the beam.
Actually, the foundation can be considered as a fixed method.
Fixed.
Yeah.
It's supposed to be a column.
Okay. This one,
Yes.
just rotate it. It will be like this. So this is the foundation. This is the column. Okay. But that's not my question. Now we are talking about beams. Okay. And in real life, the beam does not have a pin like this, or does not have a fix like this. Okay? We are an engineer, decide if we have this one and this one. You can decide always, okay? So, this is the shape, okay? This is the shape, this is the beam, okay? This is the beam, and this is here the column, right? This is the column. Because if you imagine the building, let's say that, this is the building, this is the roof, we call the slab, okay? And you have a columns, and in the end of these columns, you will have a foundations, okay? Or you can call it a footing, what else, okay? So this is the slab, this one. Here, these lines are beams, okay? Each beam have a column, okay? From the both sides, okay? So this is the beam, and this is the column, okay? And to connect the beam with the column, you need steel connection, right? You need steel connection. Okay, this is the concrete connection, but you need to put steel, okay? So let's just imagine that this is the steel here in the beam. Okay, this is the steel of this beam, and this is the steel for this column. Okay, in this case, the column considered as a pin or fixed. What do you think?
Fixed.
Fixed. Why?
Because in real life, the steel will connect to each other.
Okay, but here it's not connected to each other.
Oh, in this case, it's
Okay, so it's a fixed or a pin.
there's still concrete.
Okay, the complete connection is okay. But tell me, now there is no connection, so it's a pin. Okay, so if the steel for the beam and the column, okay, does not cross each other, okay, each of them are independent to each other. Okay, so this one is independent and this one is independent. Okay, this case is the pin case. Okay, but if you need a fixed case, you should make a connection between them. Okay, we call it splice. We call it splice. Okay, بالعربي اللي بيحكوا عربي تشريك يعني بنحكي عنه. تمام. Okay, so in English we call it splice. Okay, that this two steel or the steel here for the beam and the column are on each other. Okay, so if the steel here and here is connected to each other is a fixed, and if it's incorrect to each other, it's a pin. Okay, and you should remember this note because in the final exam I think I will have like some definition. You need to write some definitions, fill the blanks, put a circle on the right answer. Okay, and it's not like a numerical example or numerical question, it's just a theoretical one. Okay, so in the final exam you should understand both parts, the theoretical part and the numerical part. Okay, let's go back now to our exam. Now, again, we have this beam, and by the way, this beam here, the name of this beam, what the name is of this beam? Simply supported beam, right? Because you have a hinge and you have a ruler, okay? So when you have a hinge and a ruler, this is called simply supported beam, okay? When you have a fixed beam, and by the way, this point here, it's a free end. We call it free end. Why free end? Because there is no support at it, okay? So it's free. So this beam, we call it cantilever. Cantilever, okay? So in the future, if there's an engineer and he says cantilever, you should always remember this. Cantilever means that you got a fixed support from one end and the other end is a free end, okay? If he says simply supported beam, that means this is a shape, okay? If he says overhanging beam, there's many names that you should know it, okay? Overhanging beam is like this. Okay, it's an overhanging beam. Why overhanging beam? Because it's hang all these supports, okay? This is here as a seesaw, okay? You know seesaw game?
Yeah.
When one sit here and he goes up, it's the same. So it's an overhanging beam, okay? So there is a lot of names. The most three most famous important one, simply supported, cantilever, and overhanging beam, okay? Now, the question says again, draw the shear and the moment diagram for this beam, okay? So draw the shear and the moment diagram for this beam. Now, the first step always is to find the reaction. Am I right? Okay, and here we got a fixed support. So, at the fixed support, we know that we have three reactions, okay? So, I have AY, and I have AX, and I have a moment. I will assume the moment as a clockwise or counterclockwise. So this is the reaction. Now, let's find these reactions. Okay. The first equation is the summation of the forces on the x should be equal to 0 and AX equal to 0. This is the first equation, okay? Because there is no forces on the x, okay? And by the way, in the exam, if there is no forces on the x, no need to write this sentence, okay? If you want to be hurried, no need to write it, because it's obvious, okay? Now, let's go to the forces on the y. The summation of the forces on the y should be equal to 0. What the forces on the y that we get? We have a AY upward, right? It's a AY. What we get also? We have the distributed load here. It's a 20 multiplied by 4, which is equal to 80. And the distance is 2 meters from each side, because it's a rectangular, right?
Yes.
Okay, just like this. To be sure. Okay, perfect. Again, okay, we have AY and we got minus 80, right? So AY minus 80 equal to 0. That means that AY should equal to 80, right? Finally, we should apply the last equation, which is the summation of the moment at point A should equal to 0. And I will assume clockwise direction is the positive one. So, AY and AX does not make any moment here, right? At the point A, we got MA. At the point A, we got this moment, right? And I assume that it's counterclockwise, so it's a negative, right? So minus MA, minus MA, this one. And I have an 80, right? It's make a clockwise moment here. So 80 multiplied by 2. And it's with positive direction. So 80 multiplied with the 2 equal to 0. That means that MA is equal to
160.
160. Right? With a positive sign. That means my assume was correct. So I find all the reactions. I find AX is a 0, AY is a 80, and MA is a 160. Is that clear? After finish this example, we will take a break, okay? You need it? Okay, now, after we find the reaction, we should draw the shear and moment diagram, right? But before start drawing, does anyone have a question? Is that clear? It's easy to find the reaction for fixed support, right? So not a big deal. Okay. Now, this is the fixed support that we have. This is the beam. This is the load. The load is 20 kilonewton per meter. The distance was 4. Point A, point B. What was the reaction? AY was 80, and we got a moment here equal 160 kilonewton per meter kilonewton. And AX is equal to 0. Okay, now let's start drawing. Starting with shear force diagram. Positive, negative. Okay, together. Help me. Okay, now at the point A, starting with the point A, okay? We got a force on Y which is equal to 80. It's upward, right? So I should go upward here. 8 steps. Right? I go upward 8 steps.
Sorry, I'm confused. The answer for moment was positive. Isn't it supposed to be clockwise?
No, the positive sign here means the sign was positive, right? What does positive sign mean? That my assumption is correct. Like when you find the reaction, okay? You assume that MA here, my assumption was that it's a counterclockwise, right? Okay, and the sign was positive. That means my assumption was correct. If the sign is negative, that means my assumption is incorrect. So I should flip it into clockwise. Okay? So again, at the point A, the reaction was 80 upward, right? So I should go up here 8 steps. Is that clear for all of you?
Yes.
Okay. After that, when I move from point A to point B, there is a distributed load acts on the beam, right? And this distributed load is a rectangular one, right? It's a rectangular one. So, here, the line at the rectangular one is a constant, right? It's a constant. So, you have a constant, and according to the table, when you move to the shear one, the degree will change into what? First degree. First degree, right? And the first degree means that you get a straight line.
Yes.
And the straight line should be downward because the force is downward. And the equivalent value for this one, here it was 20 multiplied by 4, which is equal to 80. Okay. So now you have a positive 80, and you got also a minus 80. Okay? So the result is 0. So from here, you should go straight forward, okay, with a straight line, and it's a positive. Okay. Now continue with that. I will give you time, guys. Let's just finish this one. Okay. Now we should calculate the moment bending diagram. Positive and negative. Okay, moment bending diagram. Now at the point A, okay, at the point A, I have a moment, right? The moment is 160. The moment is 160. And this 160 is a counterclockwise. That means it's a negative, right? So here, I should start with here minus 160. Minus 160. Now, when I move on the shear diagram, there is this area, okay? I should calculate this area. And it's a triangle. So how much the area for the triangle? It's a half multiplied by the height, which is 80, 4 multiplied by the 4, right? The answer will be 160 positive, because it's a positive area, right? Now you get a minus 160, minus 160, plus 160, that means you will get 0. So you should end here, right? And because the triangle is with the first degree, when you move to the moment, it will be with second degree, right? It will be with the second degree. That means you need a curve, right?
Yes.
So just imagine a line between 2 points and draw a curve above it. So this is the moment diagram. It's easy, right? It's easy and direct forward. Okay? So have your time to write. If anyone have a question, just ask. And let's take a break. The break will be 15 minutes. Now it's at 12:30. 12:45 I will start again. Still recording, right? Please focus on me. Okay, let's solve this quiz together. Okay. So, the first step always to find the reactions. Okay? So, here we got a fixed support. So, it's AY, AX. Start coming, right? Perfect. AY, AX, and the move. There's a minute. And obviously, all of us can notice that AX is equal to 0 because there is no force on the X, right? Now, to find AY, just apply the summation of the forces on the Y should be equal to 0. And it's equal. So we have AY minus the equivalent force of this one. The equivalent force. It's like this. Okay? So, it's a 45 multiplied by half multiplied by 3, right? And it's equal to 67.5. So minus 67.5 equal to 0. So AY should equal to 67.5. And we find AY.
I think AY plus BY is 6.5.
There is no BY. It's a free end. There is no support here.
I did that's why
Okay.
this is my mistake. I know.
No problem. The idea for the quiz is just to try to solve this one. It's not calculated. But Alan, you will get an next one. Okay? So, the summation of the moment now at the point A is equal to 0. Clockwise is a positive direction. Now, we will get AY and AX does not make any moment here, right? We have MA. MA is a counterclockwise, so it should be minus MA. And here we got 67.5. 67.5. And it's a make a positive moment multiplied with 2, right? By 2. So the moment here is equal to MA is equal to, it's how much? 67.5 multiplied by 2.
Shahid.
135. 1. Okay, so we find the moment, we find the reaction, and the moment sign is a positive. That means my assumption is correct. Okay? Now, let's move to the shear diagram. Let's move to the shear diagram. Okay. This is the beam. This is the load. Let's go to the shear diagram. Positive, negative, shear, force, diagram. Now, at AY, at the point A, here, we get a force AY. AY is upward, right? AY was 67.5. So, I should go up here, 67.5. Okay? By the way, Shaheen, you was almost correct. You just missed here. Yes, it should be minus, not a positive. Okay. So 67.5. Okay? Now, we have a load here. This load have an equivalent force here. It's equal to 67.5. It's a downward. That means you have 67.5 minus 67.5. So it's a 0. So I should end here at the 0 point, right? And I have a triangle. It's a first degree function, right? When I move to the shear diagram, it should be second degree. Okay, I should go like this. Now, curve like this, curve function. Why I choose this one? Because this triangle starts with a 0 and ends with a value. And the slope here is a 0 and it's in with a value. So it's the same of here, okay? Positive. Okay, after that, let's move on to the moment diagram. Positive, negative. At the fixed support, I have a moment here, right? The moment was equal to 135 and it was counterclockwise. According to the table, counterclockwise means that it's a negative. So here I got minus 135, right? And now I should calculate this area, right? But it's not necessary to calculate it, right? Why? Because obviously I should end with where? With 0, okay? This area should be equal to 135 positive, okay? Because always you should end with a 0. No necessary to calculate this one. So this area should be 135 positive without calculating, okay? It's a logical. So now you have a minus 135 and positive 135 and the result is 0. Just imagine a line between 2 points and go up. So this is the moment diagram.
Can you repeat the last one?
Here?
The moment diagram.
Yes, this one.
Yeah.
At the fixed support, there's a moment, okay? There's a moment. It's MA. MA is equal to 135 kilonewton per meter, okay? It's a counterclockwise. According to the last lecture, counterclockwise means negative, okay? So I will go downward to minus 135, okay? Now, I have this area, okay? This area is a parabolic curve, okay? And you don't know how much the area for the parabolic curve. But logically, I should end with a 0, right? So this area should be positive 135. To get 0, you should have positive 135. So, again, you have minus 135 and plus 135. The result is 0. So you should end here, right? Now, here is a second degree curve. Here it should be third degree curve. In the moment diagram, I always say, imagine a line between the 2 points and draw the curve up of the point. Get it? It's easy one, right? You have a question?
I don't understand the shading.
The shear diagram? Okay, now at A1, here, at the point A, there's a force, it's AY. AY is equal to 76.5. Okay, so at the point A, here, I should go up to 76.5. Okay, after that, from point A to the end of the beam, there is a point, there is a distributed load. Okay, this distributed load have an effect equal to 67.5. So, positive 67.5 minus 67.5, the result should be 0. So, on the shear diagram, I will end here as a 0. Okay? So, now, how should I connect between these points? Okay? Here we have a triangle. The triangle is a function from the first degree. When you move to the shear diagram, the power for this degree increased by 1. That means here you will get the second degree curve. Okay? Now, there is two options to go by the curve, like this or like this. This triangle starts with a 0 and end with a value. Okay? So the one is like, let's say, the similar to this case is this one. Because here the slope is 0 and here the slope have a value. So I choose this one and I'm going like this. This is the shear diagram. Okay? Any questions so far? Yeah.
Why is it that after we calculate the distributed load to the point load, why didn't we choose a point from A to the line?
I didn't get your question.
We calculated distributed load to
Yes.
the point load, which is 67.5.
Yes.
Why didn't you move it from A
To the point load?
Yeah.
Yeah, you mean like I stay constant and
Nah, like, okay, you choose it from point, the free end to the, like, from point B.
you mean this distance?
Yeah, so why can't we choose one from point A? Like,
Okay, because the rule says that, this is the triangle, okay? This is P. P from the 90-degree corner here, it should be always L over 3. From the tail, it should be always 2L. Okay? So, measured from the 90-degree angle, it's L over 3. Measured from the tail, it should be 2/3 multiplied by L. Okay? Any other questions? Okay? How much time?
half an hour.
Okay. Another more example. May I? Erase one on your board. You need it? So, for the project, by the way, no one sent me the group unless Abdelhadi India, you are a group, and Mohammad Usama, Naveed and Kushal, you are a group, right? He sent it to me. Okay. The other groups, why it doesn't send it to me? This is the last time I will say. Today, send me your groups. There's a project.
We are already a group, but we forget to send.
Okay, send me the names for your group. If there is another one or anyone who does not find the group, tell me and I will put him in the group. Okay?
Is it a presentation or what?
In the group there,
I will talk about it.
in the group there should be 4 people.
how many people?
You have a question? Okay? Okay. So again, please, all of you, today is the last day. send me the name of the groups. If you want to pass this, okay? It's not for me, it's for you, okay?
Sorry, what is this group thing? Like, what are we gonna do with the group?
What you are going to do in the group, I will explain after finishing the lecture. Okay? So please, not now. Not now, please. Okay? Another example, and this example is given by our friend, Mohammad Kherais. Okay? He tried to solve this one. As he said, try to solve this one. Like this. And this is a beam. Like this. Like this, right? Let's put the numbers. Okay, let's say this is 6 meter, and this is a 20 meter, 20 kilometer, 20 meter. Okay, here it's AY, this is a point A, this is a point B. Okay, so the example again says, find the shear and the moment for the beam shown in the figure. First step, finding the reaction. Okay, so let's find it. Here, it's a hinge support, so we got AY and AX. Here it's a roller support, so we got BY. Now, it's obvious that AX is a 0, right? Because there is no force on X. Let's just apply the summation of Y is equal to 0. AY plus BY. Okay. Now we have the triangle. Okay. Now we have the triangle. So, what is the equivalent load for this one? The point load. Where is the location, first of all? On the middle, yes. Here, it's on the middle. Okay? The equivalent load is in the middle because this is a symmetrical shape. Okay? It's like this, not like this. Okay? So obviously, this triangle, the center of it, it's in the middle. Okay? So P here is equal to half multiplied with the distance, which is 6, multiplied with the height, which is 20. And this is equal to 60. So 60 down, right? Minus 60 equal to 0. Okay? Now, applying the summation of the moment at A is equal to 0, we will get that. Since it's a middle, by the way, it's a 3 meter. Okay? So we will have it's 60 multiplied by 3 minus BY multiplied by 6 equal to 0. This is the moment equation. That means that BY should equal to 30. And when you have a BY, you're going to get AY, and AY will be 30. So this is the reaction. Okay? It's an easy process, not a complex thing. We get the reactions.
So is it always the case that the triangle will be isolated?
The triangle will be
An isolated triangle. 2 equal sides. What if the next side, the sides are not equal?
okay. Yes, if it's like this, always will be in the middle. Yes.
Is it always the case that even like this, there will be a case where this side is smaller than this side?
No. There's no case. I get always this leg and this leg will be the same, so it's always will be the middle. I will not give you a case like this because it's not a mathematical issue. Okay. Okay. Let's continue now. After we find the reaction, we should draw shear and the moment diagrams. Now, this is the beam. This is the force. Let's start. No. Positive, negative, shear, force, diagram. Okay? Start. Now, here at the point A, the reaction was 30. At the point B, the reaction was 30. The value was how much? 20. 20. And the distance is 6. Right? Okay. Now, all of you, focus with me. You will have the time to write, because this is an important one. Now, at the point A, here at the point A, I have a reaction 30 upward, right? That means I should go upward 30 steps. This is 30. Am I right? Okay. Now, after that, the effect of this triangle is how much? 60. Right? So 60. So you have a 30 positive, and there's a force when you move from here to here will affect you. It's a 60. So the result is minus 30. Okay? But actually, sorry, you should end here. Minus 30. Okay? Minus 30. You should end here and minus 30. What is the curve that I should use to move from here to here? And don't forget that until here there's a triangle, and after the middle there's another triangle. Okay?
So it should be like this and this.
Yes, so we should use both curves. At the middle here, okay, at the middle here, it's a start with a 0, ends with a value. So it should be falling like this. Okay? Should be like this. After that, it starts with a value, ends with a 0. It should be like this. Okay?
This is the third equation.
Third degree?
Yeah, third.
No, second degree. Because it's a first degree, and then we move to the second degree.
But
And-
it's like the third degree.
Yes, it's like third degree. It's like x cubed. Yes, like x cubed. Okay, now there's a 30 upward, so please go up, and we end with the 0. Okay? It's very simple. So, it's a positive area, and this one is a negative area. Until here, everything is okay. I think it's easy, right? Okay. Now, let's move to the moment bending diagram. Okay? Now, please, the moment bending diagram is the diagram which we should calculate this area, right? It's the area under the curve. Okay? But eventually, we cannot calculate this area, right? Because it's a parabolic shape. Okay? So what we will do to calculate the moment?
Using the moment,
You make a cut.
Yes, perfect. We will make a cut. Okay? Here, at this point, it's a 0 shear force, right? Because the shear diagram is 0. So it's a 0 shear force. So if you go back up to the diagram and make a cut, okay, both of them, if you take this side or this side, it's okay. Both of them are triangle, right? So for example, let's take the right side. So the right side is like this. The distance is already known because it's in the middle, okay? So this one is 3 meter. And the value here is still 20. Okay? The value here is still 20. And this is the load. The reaction here is known. It's equal to 30. You will get normal force and you will get also a moment. Okay? Let's do it like this. Okay? So, direct forward, just calculate the moment at the point B. Equal to 0. So what is the moment at the point B? 30, and the normal force does not make any moment, right? We have this moment, it's a clockwise, so it's a positive. And this one, it's a 20 multiplied by 3 multiplied by half, and it should be like this. 20 multiplied by 3, it's a 60 multiplied by half, it's a 30. And the distance from here to here, it's a 2 meter, right? So 30 multiplied by 2, and it's a counterclockwise, so it's a minus 60 equal to 0. Okay? So M is equal to 60. Now I find the moment, okay? So M here is equal to 60, and it's a clockwise, okay? And according to the table, the clockwise mean it's a positive. So here we get 60 positive moment, okay? Now, just imagine a line and go up here. And no need to calculate this area, because obviously you should end with 0. So this is the mode diagram. It's easy, right? Yes. It's not seems to be easy when you face it. Okay. Does anyone have any question? Okay. You have a time to write.